Hi, good evening to one and all. I am M. Vamsi Naik. My topic is PN junction diode. This is one of the most important component in electronics. It is used in rectifiers, LEDs and switching devices. It is the PN junction diode. This is the PN junction diode symbol. This is the practical diode. That goes to the semiconductor basics. There are two types: intrinsic semiconductor and extrinsic semiconductor. Extrinsic semiconductor again classified in P type and N type. Let goes to the intrinsic semiconductor. Before we learn about the diode, let us understand the semiconductors. Intrinsic semiconductor means it is a pure semiconductor, like it is a like pure silicon, germanium. These are two examples, and it is no impurities. It is a pure semiconductor. And extrinsic semiconductor means it is a doped semiconductor, and it helps to connectivity increases. And next, formation of PN junction diode. When a P-type and N-type semiconductors are joined, a PN junction diode is formed. At the junction, electrons and holes are combining both, creating a depletion region, which acts as a barrier. Biasing of PN junction. There are two types: reverse bias and forward bias. This is the unbiased. The circuit is unbiased without giving any biasing. Uh, in P type, holes are majority carriers, electrons are minority carriers. This is the depletion region. And in N type, majority carriers are electrons, minority carriers are holes. Next, go to the forward bias. Forward bias. The positive terminal is connected to the P type, and negative terminal connected to the N type. And the P type and N type, the both are charge carriers move to the depletion region. The depletion region will be decreased. The depletion region will be it discard the current will be flow. At the same as in reverse bias condition, the P type is connected to the negative terminal, and N type connected to the positive terminal. It is in the reverse bias condition. The holes are attract to the negative terminal, and electrons are attract to the positive terminal. So the depletion region will be increases. The conduction will be not flow. Means the current will be not flow. The diode will be not conduct. In forward bias, the diode will be conduct. This is these are the characteristics. It is the silicon diode characteristics. This is the germanium characteristics. This is the reverse bias. Forward bias, after a certain cut in voltage, the current rise the rapidly. See this. At the same as in reverse bias, current is almost zero, expected for small leakage currents. I forget. In reverse bias condition, the small leakage of current will be flow because of they contain minority carriers. Depletion region. Characteristics of depletion region. In mobile ions, acts as an insulator, and width depends upon the biasing. In forward bias, external voltages reduce the barriers, current flow easily, and diode conducts. And reverse bias condition is a barrier potential increases, negligible current flow, and diode does not conduct. This is the VI characteristics. Forward bias exponential regime and reverse bias saturation breakdown regime. This is the equation, and current increases exponentially. At the threshold voltage 0.7 volts at silicon and 0.3 volts at germanium. Reverse bias characteristics, reverse saturation current with a small leakage current because of minority carriers are present in the both P type and N types. It is independent of voltage and temperature dependent. There are two types of breakdowns. Breakdown mechanism. They are Zener breakdown and avalanche breakdown. Zener breakdown occurs in is a heavily doped diode at reverse bias condition. Means it occurs a heavily doped diode at low reverse voltages. There is a strong electric fields break valency electrons. When current increases suddenly, but it is controlled. Used in Zener diode for voltage regulations. An avalanche breakdown means it occurs lightly doped diodes at high reverse voltages. Electrons, electrons gain high energy and collide with the atom, release more electrons. This chain reaction increases, current suddenly decreases. Most destructive, it is most destructive, it is not useful for normal diodes. This is the application of PN junction diode. Can use the PN junction diode in rectifiers and clippers and clampers switching devices. Practical consideration is in cut-in voltage and reverse saturation current, temperature effects. In most of the electronic components connects in reverse bias connection like UJT, BJT. Next, the conclusion: the PN junction diode it is a fundamental electronic device. It is basic for so many many applications. VI characteristics are key for understanding. This is my presentation. I think I can cover all about the PN junction practical PN junction diodes, VI characteristics and both reverse bias condition and forward bias condition. Thank you.